Good afternoon. Today is 23rd April. I am making video presentation on workshop 5. Today I have to analyze the knee brace moment frame 1 from this reference paper of Lilata Vivat. Here the beams size, bracing size and column size are given, and the plastic hinges for beams are M3 controlled. For bracings are axial load P controlled, and the columns plastic hinges are TM3 controlled. Here location of plastic hinges for beams are given as D1 and D2 distance. Here D1 and D2 distance are 125 millimeter, and right side figure, this figure shows the force versus drift ratio curve. Actually, this is the reference paper of Lilata Vivat. This is the main reference paper. Okay. For doing this, completing this workshop, I will follow some steps. They are written here. At first step, I will define material property, and then I will define frame section, and then I will draw the frame, then assign dead load on beam and making it non-linear, and then I will assign fixed support at base, then define earthquake load as user defined coefficient, then define dead load as gravity, make it non-linear, I have already mentioned. And I will define plastic hinges at selected zones and define pushover load case as a static non-linear, and then I will analyze the frame. So I have already prepared the model. For preparing the model, at first I have defined material from here. This is my material A992 FY50. These are the material properties. After defining material, I have defined the cross section properties. For beam, we saw here that for beam sections are 100 is 25 to 50, 125 69, and similarly other cross sections are given. Accordingly, I have defined all of the frames, and then I have drawn all of the frame section here. After drawing the model, I have assigned the fixed support at the base. After selecting this, I assign joint restraint. From restraint, I have selected fixed and then apply OK. Like this, I have assigned fixed support and base. After that, I have selected the beams and assigned dead load of 15 kilonewton here in this beam. So you can see that here dead load is 15 kilonewton is assigned already. After assigning the load, I have made this load pattern in going to load case, and uh, this was actually dead load. I have gone here to modify dead load here. I have rewrite this as gravity load instead of dead load, and then I selected non-linear P delta, and then I selected dead load and scaled 1. For here load application, I selected full load, and for result saved, I have selected this and OK. By doing so, after that I defined another load pattern, earthquake load here. This earthquake load as user defined load, and here eccentricity was 5%. After defining earthquake load, I defined another load case known as pushover case, pushover load. Here I have selected a static nonlinear case. Here it is gravity, and so I selected P delta effect, and load pattern is earthquake. For load application displacement control, actually, if we look here, our column height was 1950 millimeter. So if we we- if we uh, if we say that the drift is 40% of column height, then the drift is 78 millimeter. So I have here defined 80 millimeter or 0.08 meter of displacement magnitude here accordingly. And I have assigned this minimum number of saved state as 20 and maximum number of state is 100. So after this, I have defined the I have defined the plastic hinges for beams. I have defined plastic hinges manually. Like I have want to define section properties, then hinge property. This is the beam uh, hinge property, modify show property. If I go here, we can see that uh, this value actually given in main problem. So I have defined accordingly, and then I assigned this plastic hinges by selecting the beams and then assign and then go to uh, frame, then hinges. Here I have selected the uh, beam. I have selected beam and relative to distance. Here this distance is 125 millimeter. Okay, actually I have to define this separately. I have to select this and define manually. I have already defined. So after defining all of the plastic hinges, I have to run the model. Now I will run the model. Let's see what happens. So after running the model, uh, we can go to display and then show deformed shape. We select pushover and step 1, then apply. Okay. So this is the first step. If we go to second step, no plastic hinge is formed. In third step, no plastic hinge formed. Fourth step, this is fifth step. We can see that first plastic hinges formed in base of the column at step 5. If we go step 6, this is step 6, step 7. In step 7, first plastic hinge formed at the bracing. So after column base, plastic hinge formed at bracing. Then similarly, plastic hinge formed in other section except the top of the column. Now, if we go to show static pushover curve, we can go here and we can find the pushover base shear versus displacement curve, which is called capacity curve. We can show this result as table, display table. We can see that uh, in step 6, after step 6, first plastic hinge formed. We can see here. Mm. If we extract these values in Excel, extract these values in Excel, and we can find drift ratio accordingly by multiplying the displacement with 1950 and multiplied by 100, we can find drift ratio. And if we plot the graph, we get this type of graph, which is similar to similar in shape with the experimental exact result here, which is shown in this main workshop. So if we want to show other result like if we want to show uh, shear force diagram, we can show. We can select here shear 2 to step 1, show values, apply. This is the shear force diagram for step 1. Similarly, by clicking here, next, we can uh, go next. This is shear force diagram for step 2. This is for step 3. This is for step 4, 5, and this is 6, 7. Similarly, we can find the shear force diagram for every step. If we want to find bending moment diagram, we can select moment M3, moment 3, then apply. This is the bending moment diagram for step 1. We can find bending moment diagram for other steps by clicking here simply. So this figure shows bending moment diagram. If we want to show the axial force diagram, we can just select axial force and then apply. This figure shows axial force diagram. We we can note that uh, here as we as we designed the bracing only for axial force, it the bracing did not show any shear force diagram or bending moment diagram. It only show axial force diagram. Similarly, if we want to display other result, we can do so. Like if we want to show hinge result, we can find hinge result for all of the element here for different type of beam and column and also bracing. We can select just this and we can show the plastic rotation of uh, different element. We can show the result as table also. Mm, yes, this one. Similarly, if we want to display result as table, we can go to show table, display result, show table, joint output, displacement reaction. We can select here. This table shows the joint displacement of different joint in different direction. Also, by selecting joint reaction, we can show reaction for different joint here. Again, we can go to display show plot function. If we uh, want to define any plot function like for uh, joint displacement at function, suppose we want to show plot displacement function for joint 1, we can select joint write joint id 1, then okay, joint 1 display. So this figure shows the joint displacement for joint 1 for different step. Similarly, if you go to joint 7, modify, this one is also joint displacement function. So if we want to show the displacement function for joint 7, we can select this and display. This is shows, actually this is not displacement, this is reaction function. So by applying this procedure, we can find different types of uh, function as plot. Again, if we want to display uh, what virtual work diagram, we can show here by selecting apply. Okay. Actually, this diagram shows relative virtual work diagram. If we look here, the capacity curve I got here, uh, actually it shows base shear as higher, greater base shear than this one, than the actual one. It may be due to the assignment of plastic hinges. I have just uh, mm, followed the procedure what what our guide told in class. I think if we define the plastic hinges manually, this overcome should can be minimized. Thank you very much for your kind attention.